This is tutorial 3rd of Cadence Virtuoso. In this tutorial, I'll be showing how to do the layout of particular schematic. So once you are done with the design, you are satisfied with the results, whatever results you are targeting. After that, you have to go to layouts. So for layouts, you have to replace all the active sources by using pins. After that, we'll go here, launch and layout Excel, create new. Okay. So this is the workspace, and here different number of metals are there. Metal 1, metal 2, which are used for interconnection, pins are there, pads are there. So whenever you open this layout window, first of all you have to do some display settings. So for that you go to options and display, or you can press E. First of all I will do this spacing. I will reduce it. This is when you are dragging your particular transistor in X direction. So how much steps it will take, like step size. So usually we will keep it minimum for proper alignments. And also when we are editing our transistors, like moving here and there, in which what direction they should go, like horizontal, vertical, orthogonal, or we'll keep it diagonal. Okay, so these are the basic two things which we usually will do. For now this one is okay. In this tutorial I will show the basic ways to do the layout of particular circuit, but once this is done, then in upcoming circuits I will show how to do common center, how to use different techniques for mitigating the parasitics in particular layout. There are different techniques that are used, like common center are there, symmetry, dummy transistors which we use. So for now we will use basic system. Now there are three ways to bring that particular schematic transfer in here. One way is like we go simply like in schematic we used to do this. I'll go browse, I'll go to my library schematic, let you see here. I'll choose my transfer, and here I'll choose this time's layout as a view. Okay, so like this. Okay, one more thing is there in display. When you go here, these the metal numbers, how usually it will be, I think 1 here, so you have to keep it maximum. Like if you are using 10, generally there will be 10 layers of metal, so we'll keep it 10, 12, maximum it is 32 or something. Let's keep it 10. Okay, so that is the first way to bring your transfer. Go to your library and select the view layout, and you give your dimensions here, whatever dimensions you are giving there for that particular landmass, you give it here also. This is one way. Okay, this is not advisable. So another way is to go here, connectivity, generate all from source. Okay, so what it will do, it will generate all the transistors that are present in our source file, that is schematic file. It will generate their layout view in this one, like here instance. Okay, I'll do this, let's keep it like it is. Instance, I will also select generator input outputs, PR boundary I'll also select. Let's keep this, it's not required for now. This minimum separation you can put it different from when we are selecting PR boundary. So let's keep it like that for some time. So I am choosing OK, then I am press OK. So as can be seen from this figure, that the transistors are generated here and the pins are generated here. Okay, so these are different pins. Now this is okay for simple small circuits like differential amplifier, op amps. Up to op amps it is okay, but when you go for higher circuits and you are generating these all at once, you will get confused like which transistor I have to connect, and it will be all in bulk, so a lot of confusion will be there. It will add the complexity. So what I usually do, let's delete all these things. What I usually do, For complex circuits, I'll go again connectivity, generate, selected from source. So what I am doing here, I'm going to my source file and I'm selecting one particular transistor, like I want this transistor first. Okay, so it will come here. Again I'll go here, click on this one. Again, now I want to pin, select this pin, it will come here like that. Okay, so this is for complex circuits, but for now I'll just go for all selected from source, generate all from source. I'll keep it like this. Okay, now if you remember the circuit of now what I was that time saying, that when I'm moving this, I can move it in diagonal direction also. See, that was the setting I was doing earlier. One more thing is there, sometimes I'll go again here, display. If I keep it like 0.1, okay, so what it will do, if I just use the wheel of mouse for zoom in, zoom out, if I'm moving it, see what I want it to be like to be attached with this particular boundary of NMOS, but it's overlapping it. It will give me DRC errors. For this thing to reduce, I mean that step size, that thing I'm doing here only. So these are like precautions which I will do before going for layout. So 0.005 is also enough. So F is for fit again. Now as you remember that gate, this is gate, these are source or drain, you can choose, they are symmetrical, so it depends on you whether you choose the source or drain, unless you give connection to that particular pin. But before that it is source or drain, anything it can be. So first of all, what I will do, this is gate, this is poly, so gate I had connected with the basic, the poly layer, so it's PO1. Okay, so again there are many ways to connect here. So one is like I'll use this drawing, like I'll go create, I think I'll just press R is for rectangle. Okay, so I can just zoom it. See, I had to go like exactly from here. Again, if you see here, it's not allowing me to start from this one because of that step size. Okay, this will give me DRC errors. So again I'll go here, display, I'll make it 0.001. Now I'll start. See, now I can go from here. Once I click there, I don't have to click unless I reach my own that particular place where I want to go. Okay, but the thing is it's a bit here, so it will give me DRC error. So this is one way to connect. Generally this procedure, this way is not used, escape, this way is not used. So I'll just create one wire here, I'll click on this one, I'll click on this, and I want with this one. So this is it. But the problem is here, see this edge here, it will create a DRC error. So what I'll do, I'll just move this one a bit so that okay, so this is perfect now. One more thing is here, these metal layers, generally power supply will give highest layer, but since this is an inverter, I'll just keep the metal layer 1. I'll click on this, I'll go properties Q, and here this layer I'll change it, I'll make it ME1. So ME1 is metal layer 1. Okay, apply. Okay, similarly for this one, ME1, apply. Now for this one, ME1, So these are the different pins. Now one more confusion is here, which is which pin? Whether this is VDD, this is ground, I can't define from here. So one way is there, I will just click on this and I will go to my schematic. It will show me, okay, this is in. Okay, similarly if I want to see what is this pin, I'll just click on this one. I'll go to my source file and see, okay, this is output pin. This is one way. Another way is I'll click here, navigator is there, this one is there, it will show me here. I'll just ground, so this is ground. It is showing also my connections, that particular connections which I have to do for in, for out, for RDC. Okay, so first of all, now this thing is done. This is a 4-terminal device, but here only 3 terminals are there, so one more terminal is there, bulk, which I have to find. So for that I'll create one wire here, create wire, and this is the P well. Sorry, N well. And similarly for this is P well for NMOS. Okay. Now first of all, as you remember that in this circuit I have seen this bulk and this source, they are connected to the power supply. Okay, so what I will do, this is bulk and this is, I can keep it here also, it's not mandatory to attach with here, but for saying the area I'll keep it. In schematic, if you use control and wheel, it will zoom, but in this case it will move up or down. So here only wheel is fed, not control. See, you have to, these will later on create DRC errors if they are not properly done. I'll show you some examples also about that. But okay, so this is for this one. Similarly, bulk is connected here for ground. Now this is out. Okay, I'll bring this out here. This is VDD, this is ground, this is in. One more thing I'll do, I'll push this side to this one. Just keep it like this. See, first of all I'll give names to these pins. Again I'll go label, I'll just click on this one and I'll use the same current metal layer. Okay, here it is poly, but the thing is, if this is metal layer 1, this should be also metal layer 1. So what I'll do, I'll just select layer, I'll select here metal 1. This is metal 1. Again I'll write VDD space GND space IN space out. So this is VDD, this is GND in. OET. Now first of all I'll connect this input pin. Now there this is different metal layer. As you can see, this is metal 1, this is poly. So for connecting different metal layers, you have to use via. Again I'll go here. If you can see here, this is like metal 1, metal 2. If you want to connect metal 1 with metal 2, then you have to use this one. And if you want metal 2 with metal 3, then this. If there is like metal 5 and metal 1, then you have to go through series of these things. Like you can't go like directly metal 1 to metal. You have to go metal 1 to 2, 2 to 3, 3 to 4, 4 to 5. Then accordingly you have to come down 5, 4, 3, 2, 1. Okay. So here I am using poly and metal 1. So this is it, poly and metal 1. I will keep it here. Okay. Again I will select this wire. Okay. Let's click and okay, I have to change the metal layer here. Metal layer. Let's click this wire. Okay. So one connection is done. Input part is done. Now there is this ground. I can just put it on this bulb directly. Like this and connect it. Like from here to here. Like this. Okay. And one more thing is, these two are connected with each other. And like this. Similarly here, spin. Doing it like this. And I'm connecting them. Okay, so this is done. The layout is done. Now we have to go for, it's not done, this connection and placement. First of all, see the layout when I was doing first placement, placing different transistors where I want to keep, to see how I can make symmetry in my particular layout, so that parasitics will be reduced. Then I'll do connections. In connection you can also keep mind this symmetry. Now once this is done, I'll save it. I'll go to this Asura, run DRC. Now if I'm doing first time DRC, I have to attach the particular library, particular rule file that is required for checking the DRC. DRC design rule check. It checks various designs, various rules that are for this particular technology. If they are being violated, it will show errors, like some particular how much separation should be there, how much width should be there for different things. So I'll go here, view, rule X, Asura, DRC. Now here there is this one. Okay, I'll give some name, R1, start outside. Directly I can create some folder here. Here, like let's create tmp1 temporary. So all the files they will be in this one only. Okay. So tmp1. These are not required, usually we don't use them. They are optional. It's actually here different rules are there. You can skip them. And this is RS, it was there also. We can first let us see if it's working. This is the, you can watch the log file here by clicking on this. It will show you how different things are executed. Yeah, just so it is executed. It is showing us some errors are there. Do you want to see the run result? Yes. So different errors are there. So we'll click on them and click on this arrow. So it will show us where that particular error is. So I'm clicking. See, there is a bit separation here. So what I will do for this, I'll click on this wire and I'll go from here to here. Okay, now this is done. Okay, so next I'll click on this again. So I think that was related to that one only it was showing. That was also related to that one only. It is showing on there. Here again. Here this small expression is there. Again I'll create wire here. I think this is done now. It's not done. So if it is not done, so what we usually will do, we'll create one rectangle. We'll just overlap them like this. This is the spacing issue which I was talking earlier. Spacing is not letting. Same here. Again I will create one rectangle. I think this should work. Yeah, I think everything is set now. Again I'll save it. I'll do Asura, run DRC. Just press OK. File will come here. Invoice it. So now the errors have to minimize it to 2. Click on this one. Okay, this is a bit out here. What I'll do, I'll just create one big rectangle. I'll put it like this. Okay. Sura, and this is we are checking DRC only. Okay. What now? So this one also I'll replace it with one big rectangle. Sura and DRC. You can watch the log file also. So there is no DRC now. Okay. So in the process, the DRC, different DRC errors have been also shown. How can they be like how they will be there and how we can check them, we can correct them by using this window. And just close it now. So once DRC is done, everything's connections are right. So next thing is to go for LVS. Like we are comparing our schematic, our layout versus with schematic, whether everything is matching or not. If something is matching, something is not matching, it will be shown. Okay. So these are relative tools. They are generally cleared by DRC and LVS, so not required to do this ERC. Again, I'll give some name here D1, and I'll give that TMP1 folder. Here again, I have to, for the first time, I have to attach library file. This is LVS. Now here, first if you see here, it is extract tool, so I'll just click on extract. Okay. Similarly, then is compare. I'll go for again here Sura LVS. Compare. Okay, this is again switch name, they are not required. So once this is done, yeah, again I can see watch log file. Okay, it's showing here 00 errors. That's what. So there is no error, LVS error. LVS is also cleared. Everything is matching. But for example, I want to show you how LVS errors will be here. Let's take this pin in my layout. This pin, I'll delete this pin. Okay, I'll do LVS. I'll just press OK. Since in my schematic layout is there, that pin is the output pin, but in layout it's not there. So as can be seen, it is showing here one cell has had pins this way. Okay, so I'll just press OK. One window will come here. LVS debug. So this is schematic, this is layout. So once I click on this one, it is showing here. See, everything is okay, 00, but the pins, one pin is in layout schema, but it's not in layout. So this is how you can see your layout LVS errors. Okay. So what I will do again, I'll go here in schematic, I'll go connectivity, generate, select it from source, that particular pin I want to select, select it, and I'll go back to here, and I'll give it name. Use the current. Yeah, it's selected here. So now if I select it, I'll do SORA again, LVS. So again there is no LVS. So once this LVS is done, it is showing a schematic and layout match. Once DRC is cleared, LVS is cleared. Now next thing is extraction. How to do parasitic extraction. We have to see how many parasitics are there. Okay. Again I'll go here, Asura RCX. This is for extraction, parasitic extraction. Let's close it. This is the setup directory address. For this again, Rolex, Asura, LPE. Okay. This is it. One more thing is here, you have to select your power nets here. So one power select from schematic, like this, select this one, VDD, okay. So it will come here. Similarly for ground nets, select from schematic. Okay, I go to schematic. I'll write it, ground. This is all, let it be. So let's go for extraction. Next. reference node required. Why is that tab 1? Something was missing here. Okay, click VDD here and watch that file again. So it is done completely, and the output is that in my library, that particular cell, and we use AV extracted. So I'll go to my library. This is our library inverter. This is here. I'll just double click on this one. This is the RC extractor view of our inverter. Now if you zoom it, you'll see different parasitics here. Like these are all parasitics, small resistors you have seen. These are all parasitics, capacitors, resistors. This is our transistor here. This is transistor. All are the parasitics. So up till now what I have done, we have created the layout of inverter, we checked the DRC, then we went for LVS. Once everything was passed, then we went for RC extraction, and I showed you how the different parasitics are present in this. This is like only 2 transistors, but when you go for like at least 10 transistors, 20 transistors, you can imagine how many parasitics will be there. So that there should be one proper technique, like symmetrical techniques we are using, commons, and there are different techniques are there, which we can't properly eliminate them, but we can mitigate them. We can mitigate the number of parasitics. So in the coming tutorial, I will show how to compare the results of different results of schematic and layouts. Obviously, some because of those parasitic capacitors, there will be some delay in case of inverter, and we'll also see which are called post layout simulation. We'll see them in next tutorial. Okay, thank you.